All right, everybody, this is Mr. Ainsworth again. We're going to continue working on activity 7E4 here in MRWC, here at Great Oak High School. In the previous video here, I just went through number 1, which took a while because there's 8 functions which we had to show symbolically whether they are odd or even by using the definitions of even and odd. In the previous activity on 7E3, this one here, we did the graphical approach using Desmos. That was fairly straightforward. We just look at the graph and determine, based upon its symmetry, whether it's odd or even. Even meaning that it has y-axis symmetry. Okay, it's a reflection across the y-axis. Or odd meaning it has rotational symmetry about the origin. I'm talking about 180-degree rotational symmetry about the origin. Or you can think of it as a double reflection. You know, first across the x-axis and then across the y-axis. Okay, and so we discussed that in 7E3, and then in 7E4, I went through the same functions. That's why I put them side by side to show that they are even or odd by using the symbolic definitions of what it means to be even or odd. And so we went through all of these. Now what we're going to do is we're going to take sums and products of these 8 functions in number 2, and we're going to prove certain facts about them. So we're going to go to number 2. Parts A all the way through D, so there's only 4 parts, and go through and finish this activity. So let's get started. And so what we're going to do, let's read it first. For each of the following, find an equation of the newly defined function. We call this one s of x, and it depends on what's going on here. We just have to read it. Then use the symbolic definition, okay, symbolic definition of odd or even functions to determine the new function is odd or even. Okay, so we have to use the same process as above. So what I talked about in my last video is a 3-step process basically. So take a look at the top here. We substitute in negative x in for x, that's step 1. Step 2, we simplify. Step 3, we analyze the result and determine if it's even or odd based upon their definitions. Well, we're going to do the same thing. Okay, so what we need to do is take f and k, functions f and k, multiply them together, and check this conjecture out. Now, conjecture is an educated guess, like a hypothesis, and we want to show that the product of 2 even functions is even. An even times an even is an even function. Okay, and we already know this one right here, so if we just go off to the side and take a look at activity 7A3 off to the right here, this happens to be, it happens to be part A. Take a look at right here. We did it graphically. But we use these functions up here. So we don't want to do the graphical approach again. We know that a product of 2 even functions is an even function. We did that already. An even function times an even function is an even function. That was a true statement. We did it graphically. Now we do it symbolically. So we're taking our skills and applying it to the new concepts, that meaning the symbolic definition. All right, so let's grab these functions f and k. They happen to be right above. Okay, f is, let me see here. F of x happens to be the first function here. F of x equals 3. And then we want to multiply f times k. These are 2 even functions. K of x, let's see, that's this one, part f right here. It's the square root function. So what we're going to do is we're going to take these 2 even functions. We know they're even because we already did it, okay, 2 different ways. And we're going to multiply them together and show that the product is also even. But we're not going to use Desmos, okay? No Desmos. No Desmos, okay, initially. We can do it afterwards, okay? We can verify afterwards, but not initially. Okay, so here we go. Let's write out the function first. We have to know what s of x looks like. So f times k. So s of x, our sum function, our function here, they just call it not a sum function, it's actually a product function, is f times k. So function f is 3 times k, and it's the big root function that's up at the top there, so times the square root of, let me see, let me reduce this here, the square root of 2 minus x times 2 plus x, okay? So k, f of x is this constant function. It's a very simple one. It's only f of x is equal to 3. That's an even function. We multiply it by k of x, which is an even function, and we have to show that we get an even function. So it says the product of 2 even functions is an even. We know this is a true statement. Okay, so here we go. What we do is we follow the procedure. Okay, we substitute in, here, let me write it down here. Okay, so step 1, we sub negative x in for x, Then step 2, we simplify the result like we did 8 times above, okay? And then step 3, we analyze, okay? And analyze the result. And we compare it to the definition. So it's this 3-step process. So let's do it again. So let's take s of negative x this time, and I have to substitute it in wherever I see x. So I see x in 2 different locations. So here we go. So it's going to be 3 times the square root of 2 minus negative x times 2 plus negative x. Let me highlight where I substituted. So I have to substitute in wherever I see x. I got to take out x and put in negative x. I got to replace it. That's what substitution is all about. And then step 2 is to simplify. So let's do that. Let's just use our common sense. So I got 3 times the root. Okay, 2 minus a negative x is the same thing as 2 plus x. And 2 plus a negative x is the same thing as 2 minus x. And then if you compare these two, if you compare the original, the function, which is s of x, with the new function s of negative x, you notice that these are the same. These are equal, right? They're equal. So this is equal to the original function, which we call s of x. So I know that s of negative x equals s of x, and that tells me that we have an even function because that's the definition of even. So let me go up to the very top. The definition of even that we've been working with in the last activity was that if it's even, any function f of negative x equals the original function. So if you substitute in negative x, you should get the original function, which we did, okay? Which we did, okay? We substituted in negative x, I got the original function, and therefore it's even. Now, if you want to type this in Desmos to show it's even, you can. We did that in the previous activity. So again, if you want to do that, do it again, which would probably be a good idea. I'll do it one time here just to get things rocking and rolling here. So let me bring up what we did last time. Let's bring up now since we saved our work in Desmos, you just have to pull it up. Here are all the functions that we worked on. And that's what's cool about saving your work in Desmos and having an account, because you get to use it. Okay, so I need here's my second function. I need to multiply it by 3. So let me just modify this, multiply it by 3, and turn the function on, and notice that it's even. It has y-axis symmetry. In fact, let me just bring that in. And this is how we checked in prior activities that a function is even or odd. We did it graphically first by looking at symmetry, and then we learned how to do it symbolically. Okay, so here it is. Okay, let me just rearrange things here. So there we go. So we have this function. I'm talking about this one right here. So not these. Okay, and this function has symmetry about the y-axis, and the y-axis happens to be this dark line right here, this vertical line. It's the y-axis. Okay, and you'll notice that this point A gets reflected to A prime, and it gets reflected across the y-axis. We call this y-axis symmetry, and because of that, we call it even. Okay, so there we go. So you can check your results in Desmos. And we've done it twice before, but if you still need a review, go ahead and type the function in and check it out. All right, but you got to learn this symbolic approach. Okay, versus the graphical. So this is obviously the graphical approach here off to the right. Okay, and then the symbolic approach is what we did algebraically here. And that is part A. Okay, now let's take a look at this one here. So we have to take a look at the new function, call it t of x, and we have to see if, well here, let's read our conjecture. We have to check this conjecture. The sum of the two even functions is an even function. So we got to take g, which is even, plus another even function, and show that you get another even function. Now, if you don't know about that, we did that earlier. Okay, so let's go back to 7e3. This is what I love about this technology, because we've done this before. It happens to be, okay, it happens to be this one right here, part D. All right, an even function plus an even function was an even function. We did that with Desmos. All right, and so what we want to do is do it again, but we want to do it symbolically, right? Because we're learning new skills. Okay, so here we go. Let's get these functions in. So G, you gotta look above and get G. Now G of X happens to be, this function here is negative 3 cosine X plus K. What's K? K is the log function, you can look above. Log base 10 of the natural value of, the absolute value of X minus E. Okay, that's our new function, call it T. You can verify what I just said just by looking up here. Okay, so G of X is up here. It's part E, negative 3 cosine X. And then what other function we're using? K of X, cap A. So cap K. So capital K is, where is it? So it's part H. It's right here. Okay, so you take these functions above, you bring them down, you add them up, and you get this new function. Okay, we'll call it T. And just keep changing the variables up because it doesn't matter what the name is. Okay, so we have to show that an even function plus an even function is an even function. So here we go. We substitute in, again, the first step of all of these processes here, you substitute negative X in for X, you simplify the result, all right, and then you analyze. That's the three-step process that I've been talking about. Oops, analyze, here we go. So step 1, substitute. Step 2, simplify. Step 3, analyze. So here we go. We're going to substitute in negative X. Now I have to substitute it wherever I see X, and it's in 2 different positions. So I get negative 3 times the cosine of negative X plus the log base 10 of the absolute value of negative X, and then minus E. So notice that I substituted in here and here, okay? All right, now I simplify. So step 2 is simplify. Well, we talked about in the previous activity what cosine of negative X is. So let me go back up. Where was it? No, okay, so right here. So we talked about in the previous activity that or in number 1 actually, okay, part E, okay, the cosine of negative X is equal to cosine X because these are even functions, okay, this function here, so this function and this function, okay, these are equal functions. They're equal. We checked it with Desmos, all right, and that's why I could replace cosine of negative X with cosine X. Cosine of negative X is the same function of cosine X. You check it with Desmos. I did that in my last video. Okay, so you just check that because that's a fact, okay? And if you don't remember, well, then pause the video and do it, okay? Put it back in Desmos so you can see it. So I know right now that this is negative 3 times cosine of X. These are equal now, all right? Plus, and I get the log of base 10 of just the natural, I keep saying natural log, the log base 10 of absolute value of X, okay? I know that the absolute value of negative X equals the absolute value of X. I discussed that, okay? So I'm going to put recall here because I discussed that in my previous lesson here, or in my previous video, that these are equal, okay? You take the absolute value of the negative, you get a positive, okay? It's that simple. And then minus E. And then notice, okay, that these functions here, okay, are the same, okay? They're equal. All right, which means that, okay, this is equal to the original function, t of x. So I substituted negative x, I got t of x. So I got the original function right here, which tells me that we have an even function algebraically. Okay, so this last step here, right here, this is the definition of even, and that's key. So if you substitute in negative x and you get the original function, it's even. If you don't get the original function, it may be odd, or maybe neither. It depends on what happens. So don't assume that it's not even means that it's odd. Okay, don't assume that, because sometimes they're neither even or odd. Okay, and you could verify this. Verify with Desmos. Okay, so verify with Desmos. You put that in. Just type in the original function and look at the symmetry. Okay, look at the symmetry of what you got. All right, now part C. We got to show, the conjecture is that a product of 2 odds is not an odd function. So it may be even, and it may be neither, but it definitely is not odd. An odd times an odd is not odd. Okay, so what I'm saying is that an odd function, times another odd function, okay, does not equal to an odd function. So you have to show that it's either even or neither. Okay, so I'm going to write that down. So show even, okay, or neither. That's what you have to show. So let's get h and f. They're above. Now again, all these functions are above. You're using these functions that we just worked with. And h is part b. And then what else are we using again here? Cap f. Okay, so cap f, when I say cap f, I'm talking about capital F. That's part c. So we're going to use these two functions right here. All right, so let's bring them in. Here we go. So let's write out the function first. So our function v of x, our new function, is the product function. And it looks like h, which happens to be negative x cubed, okay, plus 2x, times f, so I'm just going to use parentheses here, capital F, which is x plus 1 over x, okay? C above for the functions. Okay, I'm talking about number one in the activity. They're there. And so what we want to do is this, we have to show that an odd here function times an odd function is not, okay, is not equal to an odd function. That's what we have to show. So what we have to do is substitute in negative x. So here we go. So let's substitute in negative x. And then this one here, I have to substitute it in 4 different locations. I mean, when I say substitute in for x, I'm saying substitute everywhere. So here we go. So negative of x cubed plus 2 times negative x. I'm going to switch. I'm going to make square brackets just so you can see it better. There we go. All right, and times negative x plus 1 divided by negative x. You just substitute it everywhere you see x. X goes out, negative x goes in. That's all you do. And then you simplify. And guess what? We've done this before, okay? I did that up here in the previous activity here in part B and C. I did both of them, okay? So you have to go back. If you're not following me here, then you go back and you look at what we've done in the prior lesson, because you're supposed to learn from prior lessons, right? And then apply what you know. That's called learning. Okay, so here we go. So negative x to the third power. Now, negative x to the third power is just negative x cubed. All right, 2 times negative x is just a negative 2x. So I simplified that part. Times negative x and then minus 1 over x. I'm just going to bring out the negative. You can use round parentheses or square brackets. It doesn't matter. They're just parentheses. Okay. Now, a negative of a negative is positive, so we just get x cubed here, minus 2x. And the other one, you don't have to do anything because it's already simplified. Now, if you compare the two, all right, x cubed minus 2x is different than negative x cubed plus 2x, the original function. Now remember, this is what we start with is the original function. We always compare it with this. So you got to compare to the top. Compare. I'll write it down. Compare. Now, negative x cubed plus 2x is different. And notice x plus 1 over x is different than negative x minus 1 over x. And notice that those are opposites right there. In fact, both equations are opposites. Holy cow, they're both opposites. All right, so this portion here, this portion is the opposite of the original function. So we can say that it's opposite of that function, which is negative x cubed plus 2x. Or you can think of it as factoring out a negative too. Now you can check this because if you distribute through the negative, you get the previous step. Okay, a negative times a negative is a positive, and a negative times a positive is a negative. And the same thing over here. These, the negative x and the negative 1 over x, is the opposite of the original function f. Okay, and so it is also the opposite of that function. So I'm going to write that out. Now, I'm going to highlight the 2 negatives that I'm going to be looking at here. So check this out. Look at this negative and look at this negative here. A negative times a negative is a positive. So I can say that this gives us negative x cubed plus 2x. all right, times x plus 1 over x, which happens to be the original function v of x. Okay, so if you start off with v of negative x and you get the original function, which is what I ended with here, this is called the original function, okay, you know that you have an even function, okay, and that's by definition. Whenever you substitute a negative x and you get the original function back, you have an even function, okay, and I just showed that it's not odd, because if it's even, well, then it's obviously not odd. So I just proved this conjecture right here. Okay, we had to show that a product of two odds, an odd times an odd, does not give you an odd. And since I showed it's even, well, I did my job. Okay, now that was fairly intensive. So if you need to watch that 2 or 3 more times, pause the video right now and rewind it. Okay, but that's how math is. Sometimes it takes 2 or 3 doses to kind of get it. Okay, for a light bulb goes on. When I watch videos and I learn from other people, I rewind all the time. I rewind and listen to it, and I do it, and I repeat it as many times as it takes to get it. All right, so if I do it, maybe you guys should try that. Okay. Now we got to try this conjecture here. Now this conjecture is a little different, so let's read it. The conjecture is that the sum of 2 odds is not an even. Okay, so we have to show that an odd function, all right, plus, I should write the word function because it's not a real number. So an odd function plus an odd function is not equal to, that's a not equal sign, is not equal to an even function. So maybe it's odd or neither. Okay, so what I have to do is I have to show odd or neither one of the two, either one, just like I did on the last one. Okay, so this is odd and this is odd, and so let's grab these functions. And again, g and h are right above. Okay, so g of x is in part g here, and then h is in part d. So here we go. Let's bring them in and let's work with it. Last one. Okay, so we got to write the new function. So g of x, that looks like the cube root of x. Let's call the cube root of x. H of x is equal to the sine function. So the sine function here. Okay, let me just verify that. So g of x, yeah, the cube root of x. That's this one here, and then the little g. No, excuse me. Where's the other one? Oh, h of x is sine x. Okay, so I wrote them down correctly. And then what we want to do is add them up and show that an odd plus an odd is not even. Okay, we have to show that it's not even. Here we go. So what we do what I've been saying all along. We substitute in, all right, substitute negative x in for x and see what happens. So we start off with w of negative x, and we substitute it in the cube root function. So the cube root of negative x plus the sine of negative x. So notice that I just substituted wherever I see x. X comes out, negative x goes in. And then you simplify. Step 2 is simplify. So step 2, simplify. Step 1, substitution. Step 2, simplify. Step 3, analyze. Okay, so here we go. Let's simplify. Now the cube root of negative x is the same thing as negative of the cube root of x. Not sure if I've explained that before or not. So let me just do a little thing here. If I take the cube root, let's say, of negative 8, I get negative 2. You can check that in Desmos. If I take negative of the cube root of 8, I get negative 2. So these are equal because it's an odd root instead of an even root. So this is always true for odd roots. It's not true for even roots. Okay, so a little side note right there. Okay, the sine function, I did talk about that. Now the sine of x is equal to, this portion right here is equal to a negative sine x. Okay, now if you don't believe me, let me just do this one more time. So I'm going to go to Desmos real quick and show you that these are actually equal. Okay, so I'm going to start down here. I'm just going to enter in the sine function just to prove my point real quick graphically. Okay, just to make sure you believe me here. There's the sine function. And then the other function, the negative sine x, that should be the same thing. So y equals negative sine of x. Watch this. I gotta choose the right function here. Okay, so I gotta put in negative sine x here up top. Okay, so I'm gonna turn off the second function. Okay, so you see that in red, this is the sine of negative x, and I said it's equal to negative sine x because these are odd functions. So if I turn on the other one here, notice that we don't see anything different because they're overlapping, they're the same thing. So sine of negative x equals negative sine x. Okay? Okay. So these are equal, and then notice they're both negative, okay? And notice that they're both the opposite of the original function. So you got to compare. Again, you always compare to the original function. Okay? And notice that both of the parts of the function here, like the cube root function, now we see negative cube root of x. Sine of x, negative sine x. So it's the opposite of it. So this is the opposite of what we started with, which is the cube root of x plus sine of x, which we call, just in general, w of x. So if I just bring what we started with down here, I see that w of negative x equals negative w of x, and that implies you have an odd function by definition. Okay? Because again, I'm going to go back up to the very top to what we started with here. Okay, by definition, if you take a function and substitute a negative x, which we say f of negative x, and you get the opposite of the function, look at the definition at the top of the screen here, all right, you get an odd function. If you get the same function, you get an even function. If you get the opposite of the original function, you get an odd function. And believe it or not, it's as simple as that. Okay, so I showed that it's odd and not even, so I achieved my goal. Okay, we had to show that an odd function plus an odd function is not even. I showed it's odd, so therefore it's not even. Okay, so not even. And there we go. That is the complete activity done in 2 videos here. Again, this is all about 74 here in MRWC. I'm Mr. Ainsworth. If you need some more help, just see me in class, okay? Actually show up. A lot of you guys aren't. Not good. So show up in class, come to intervention, work hard, all right? And have some grit, okay? Because, you know, that's a more important factor of success than believe it or not, than actual mathematical ability. I've known plenty of people who are capable of getting an A in my class, and they fail. All right, because they don't have grit, they don't have work ethics, they don't have desire, they don't have everything that it takes to succeed, except they might know some mathematical ability, but they don't use it. So people that don't use their skills, they don't succeed. All right, and I need you guys to actually put forth some effort, put forth some grit. I'll see you in my next video. Bye-bye.